Imagine spending $34 million in 1960s money, only to watch your jet leak fuel like a broken faucet. To any engineer, this leak would be a fatal flaw. But for the Blackbird, this mess was a requirement for survival, because on the ground the plane was broken and bleeding. Yet at Mach 3 it transformed into a machine of fire. That transformation is what we call the steel paradox. To solve the mystery, you must first understand the heat. Friction at 3,000 miles per hour creates a furnace. This friction heats the titanium skin to 600 degrees Fahrenheit. At that temperature, the metal expands and the aircraft grows. The gaps were the only way to keep the pilots alive. But this mechanical leaking was only the first layer of a much deeper secret. The fuel itself, a miracle called JP7, was so stable it defied common logic. While ordinary jet fuel would explode, JP7 was designed to act as a coolant. It circulated through the wings, soaking up heat before ever reaching the engines. Without this thermal exchange, the entire titanium frame would simply melt away. Because this fuel was so cold, it required a dangerous chemical to ignite. But even with miracle fuel, the Blackbird faced a ghost in the machine, the Unstart. At Mach 3, the air isn't just wind, it's a solid wall of pressure that must be tamed. Huge movable cones inside the engines position themselves to trap supersonic shock waves. If the cone fails by even a fraction, the shock wave is expelled violently forward. The engine stops breathing. The plane yaws so hard it slams the pilot's head against the glass. It feels like a mid-air collision at 2,000 miles per hour, a terrifying steel paradox. But even after surviving the Mach 3 furnace, the Blackbird faced its final paradox during landing. The heat was so intense that ordinary rubber tires would have vaporized before touching the runway. To solve this, engineers created a unique tire infused with powdered aluminum to reflect the heat. Each tire was filled with nitrogen instead of air, preventing a massive explosion upon touchdown. At over 200 miles per hour, the landing was a high-stakes dance between metal and asphalt. Even at a standstill, the jet remained so hot that ground crews couldn't touch it for hours. Stopping a Mach 3 beast on a standard runway required more than just aluminum tires and nitrogen. A massive orange drag chute had to be deployed instantly, or the jet would simply run out of tarmac. The force was so violent that the airframe would groan under the sudden deceleration of several Gs. But the real work began only after the engines were cold. Each flight was followed by a total inspection. Mechanics had to check every single titanium panel for heat-induced stress cracks that could be invisible. It took nearly 1 week of maintenance for every single hour the Blackbird spent in the sky. Because the Blackbird leaked so much fuel while sitting on the tarmac, it was physically and technically impossible to take off with a full load of JP7 without risking a catastrophic structural failure. Every single high-speed mission required a specialized reinforced tanker plane, the KC-135Q, to be already circling in the stratosphere, waiting to feed the hungry jet immediately after its climb. This specific tanker was a flying vault, carrying the only fuel compatible with the SR-71, kept in completely isolated and pressurized tanks to avoid even a single drop of contamination from standard fuels. Immediately after breaking ground, the pilot had to hunt for its partner in the clouds, docking the aircraft to drink thousands of pounds of fuel before those massive J-58 engines finally went dry. Connecting these two giants at 500 miles per hour was a dance of death, where a single wrong move could cause a mid-air collision that would vaporize both crews in a fraction of a second. But the most dangerous paradox of the Blackbird wasn't physical, it was political. To build a jet out of titanium, the US had to buy it from their greatest enemy. The Soviet Union held the world's largest supply of titanium, the only metal capable of surviving Mach 3 heat, but they would never sell it to the Pentagon. So the CIA created a massive network of ghost companies and fake front organizations to buy the metal from the Soviets under the guise of civilian industry. In the ultimate irony of the Cold War, the Soviet Union unknowingly provided the very material used to build the aircraft that would spy on them for decades. The SR-71 wasn't just built to fly fast, it was built to see everything. Its cameras were technical marvels that could photograph a golf ball from 80,000 feet. To prevent the Mach 3 heat from distorting the images, the camera windows were made of pure quartz, fused directly to the titanium airframe using ultrasonic waves. During a single mission, the Blackbird could survey over 100,000 square miles of enemy territory, capturing every detail on miles of high-definition film. But there was a catch. This wasn't digital. The film had to be physically recovered and developed before the secrets of the Soviet Union could be revealed. At 80,000 feet, the air is too thin to sustain life. To fly the Blackbird, you didn't just wear a uniform. You wore a full-pressure spacesuit. If the cockpit depressurized at Mach 3, the pilot's blood would literally boil in seconds. The suit was the only thing keeping the human soul inside the metal god. Pilots had to eat their meals through a silver tube inserted into a small hole in the helmet. Pureed food was the only fuel for the man behind the machine. Every breath was monitored. Every heartbeat was a data point. In this cockpit, there was no room for fear, only for the cold logic of the mission. During its decades of service, the Blackbird faced the most advanced anti-aircraft systems the Soviet Union and China could build. More than 4,000 surface-to-air missiles were launched against it, but not a single SR-71 was ever touched by an enemy strike. The pilot's standard defensive maneuver was simple yet terrifying: push the throttles forward and simply outrun the missile's explosion. At Mach 3, the laws of physics were the only armor the Blackbird needed. It moved faster than the very signals sent to kill it. Despite its invincibility, the Blackbird's greatest enemy wasn't a Soviet missile. It was the digital revolution and the rise of the spy satellite. Satellites could watch from space without leaking fuel or requiring a tanker. The steel paradox was becoming too expensive for a world that preferred pixels over titanium. In 1998, the engines were silenced for the last time. The aircraft that once turned the sky into a furnace was moved into the cold silence of museums. But even in retirement, the Blackbird remains a ghost that haunts the limits of physics, a reminder of a time when we dared to build the impossible. But legends of this caliber never truly vanish into history. Even now, decades after its last official flight, rumors persist of a successor hidden in the shadows of the Mojave Desert. They call it the SR-72, the son of Blackbird. While the original Blackbird conquered Mach 3, this new Phantom is designed to scream through the atmosphere at Mach 6. It bridges the impossible gap between a traditional jet engine and a hypersonic rocket, turning air into plasma. The steel paradox was more than just a plane. It was a testament to a time when humanity dared to touch the sun with titanium hands. It proved that sometimes, the only way to survive the heat is to embrace the expansion. Today, the Blackbird sits in silence, a sleeping god of the Cold War. But every time a sonic boom echoes in the high desert, we are reminded: speed isn't just a number, it's the ultimate form of freedom. Welcome to the legacy of the steel paradox.